Hello class. Today we're going to be looking at adding and subtracting mixed numbers. So what you're going to need for today is your Chromebook, your daily notebook, and your pencil or pen. Okay, today is going to be a 2-day lesson. We're going to do most of the lesson today and we will finish the lesson next Tuesday. Okay, so let's dive into this lesson. First thing, in order to be successful today, what you need to be able to do is add and subtract both positive and negative mixed numbers. So we've done probably before, back in 5th and 6th grade, mixed numbers where you were adding and subtracting those, but now we're going to throw in some integer rules. So that's why it's very important for you to understand those rules. That's why I didn't want you using the calculator when we were doing the integers. Okay, so what I'd like for you to do first is I want you to do just a little warm up. Okay, so I want you to pause the video and answer these two questions. Okay, so let's see how you did. Okay, so this is kind of reviewing our integer rules, okay, and we'll need those in just a little bit. Okay, so the first thing I've told you to look for is addition. Make sure the entire problem is an addition problem. So you'll notice right here, it's all addition. Okay, so if it's addition, I start putting my positives together and then I put my negatives together. So if you'll look, I've got an 18 and a 5 that I can put together. And when we add those together, you end up with 23. Plus, and now we take our negatives and put those together. So I've got a -6 and a -12. If you add those together, you get a -18. Okay, so once we've done that, we do one subtraction problem. Because my signs are different, so we subtract. And you end up with 5 as your answer. And it's going to be a positive 5 because the 23 is farthest from 0. It has the greatest absolute value. Now, when you're dealing with the second question, hopefully you saw that there were some subtraction problems there. There was some minus parts. So our rule is change subtraction to addition, next number to its opposite. And then we come down here, we see another subtraction, change subtraction to addition, next number to its opposite. So now the problem really is -11 plus 10 plus 16 plus 8. And that's the real problem that we have. So now we're going to take all of our positives and add those together. So that means I've got a 10 and a 16 and an 8 that I can add together. So 10 and 16 make 26. 26 and 8 make, 34. So I've got 34 plus -11. So 34 plus -11, our signs are different. So we now subtract. So we do 4 take away 1 is 3. 3 take away 1 is 2. And again, my answer is going to be positive because the 34 is farthest from 0. Okay, so that's reviewing those integer rules. And we're going to need those in order to add and subtract mixed numbers. So why are we doing this? Well, one, we need to remember that our standard that we're working on right now is just to add, subtract, multiply, and divide rational numbers fluently. So that means we have to be able to add, subtract, multiply, divide any integers, fractions, and decimals. Okay, so the first question I have for you then is, what does 5/8 look like? If you were to draw me a picture of what 5/8 looks like, what would it be? Pause the video and draw me a picture on your notes. Okay, so let's see how you did. There's typically 2 pictures that I will see with 5/8. Okay, one is the candy bar example, or what I call the candy bar example, where you're given a box, and we're going to chop this box into 8 pieces, and we're going to shade in 5 of them. That's 5/8. That's one example. The other example that you're going to see is the pizza problem. Okay, where you've got a circle, we chop the circle into 8 pieces just like they would a pizza, and you shade in, again, 5 of those pieces. That's what 5/8 looks like. Because our bottom number tells us, this denominator tells us the number of pieces we're going to have to make 1, and the top number tells us how many of those pieces I actually have. Okay, so that's what 5/8 looks like, and that's what we need to remember about fractions, is the root definition. So let's talk about addition and subtraction of fractions then. What have you learned in the past? Well, I'm hoping that what you have learned is that I cannot add these together as they are, because they are different size pieces. So what we have to do is we have to find a common denominator. So I've got to make this 8 and this 12 look alike. So the way you do that, and the easiest way to do that, is you take the 12 and start going through the multiplication facts of 12. So you do 12 times 1 is 12. Could I turn this 8 into a 12 using multiplication? And no, we can't. So then I go 12 times 2. 12 times 2 is 24. Could I turn the 8 into a 24 with multiplication? Yes, I can. And that becomes our common denominator. So I've now changed my bottoms. Now what you've learned is whatever I do to the bottom, I must also do to the top. So how did I go from 8 to 24? Well, I multiplied by 3. So I have to do the same thing to the top. And I come up with 9. What did I do to this 12 to turn it to a 24? I multiplied it by 2. So I multiply the 5 by 2 to get 10. Now that these pieces are the same size, I can add them together. Here I've got 9 24s. Here I have 10 24s. How many 24s do I have all together? Well, I have 19 24s. Okay, so the answer is 19 24ths. And then the last question you ask yourself is, does the 19 and 24, do they have anything in common other than 1? Could I simplify those? And in this case, no. So 19 24ths is my final answer. Well, what about subtraction? Is subtraction the same way? Yes. For subtraction, instead of adding them together, we just subtract, but we still do the same thing. We find a common denominator. So I'm going to rewrite my fractions with a common denominator. Now, sometimes it works like this. 5 and 3, the first number that they're going to have in common is 5 times 3. Because you go 5 times 1, can I turn the 3 into a 5? No. 5 times 2 is 10, can I turn the 3 into a 10? No. 5 times 3 is 15, can I turn the 3 into a 15? Yes. So one way to find a common denominator is to always just multiply them together. And you could have done that with the 12 and the 8. Okay, and got 96 as your common denominator. But the larger the denominator, the more simplifying you have to do at the end. So the easiest is to find the least common denominator. So now how did I go from 5 to 15? By 3. So I do 4 times 3 to get 12. How did I go from 3 to 15? By 5. So I multiply the 2 by 5 as well and get 10. And now instead of adding, what we have to remember to do is to subtract. So here I've got 12 15s. I'm taking away 10 of them. So I'm only left with 2 of them. Okay? And that would be my final answer because you can't simplify that any further. So what did we do? Okay, so what are the steps to add or subtract basic fractions? Well, the first step was to find a common denominator. That's always our first step. Make those bottoms look alike. The second, change your numerator to match. Whatever I did to that bottom number, I got to make sure I do to that top number as well. Okay. Then add or subtract your top numbers. Okay. Keep your new denominator, whatever that was, keep it. And then last but not least, simplify. Now what we're really focusing on today is mixed numbers. So if I were to give you a problem like this, how do you think those rules are going to change? Well, is the first step going to be the same? Yes, we're still going to find a common denominator. Is the second step going to be the same? Yes, it's still going to be the same. Change your numerator to match. Now some of you back in elementary school, you've been taught that, oh, Mr. Nash, all we got to do is change this into an improper fraction using the popcorn method, and then I just add them. No, you can't do that. Okay? That's not what we do in addition or subtraction. In multiplication, yes, that's what we do, but not in addition or subtraction. Because any way you look at it, you're still going to have to find a common denominator. Okay, so find a common denominator, change your numerator, add or subtract your numerators, keep your new denominator, but here's where the thing changes. We now have whole numbers that we've got to take into account. So we're going to add or subtract our whole numbers, and then, last but not least, we're going to simplify. So those are the steps to add or subtract mixed numbers. So let's try that. Okay, so here's our problem. We got 5 3/4 plus 6 5/8. So the first thing that I'm going to do is I'm going to rewrite 5 with the new fraction bar plus 6 and a new fraction bar because I need to find a common denominator because that's my first step. So I ask myself, here I've got an 8. Can I turn this 4 into an 8 using multiplication? Yes, I can. So that becomes my common denominator. Now I could have done 8 times 4 to use 32, and that would be just fine. But that's going to give me more simplifying at the end. I'm kind of lazy, so I don't want to do more work if I don't have to. Okay, so now how did I go from the 4 to 8? Times 2. So I do the same thing to the 3 and get 6. What did I do to this 8 to turn it to an 8? Absolutely nothing. So don't do anything to the 5. Okay, and so now our fractions are the same size. So we changed our Denominator, we found a common denominator. We changed our numerator to match. So next is add or subtract your numerators. So in this case, we're going to add our numerators. 6 plus 5 gives me 11. And then next step is keep your denominator. And now add your whole parts. 5 and 6 make 11. And then last but not least, we try to simplify. Now, if you give me this as an answer, you receive part credit, because that tells me you understand how to add fractions to mixed numbers. But the second half of the problem is to simplify. We have to know how to simplify. Okay, so when you have an improper fraction, the way we simplify is we divide. We take this 11 and we divide it by the 8. 11 divided by 8. And you do the division. 8 goes into 11 one time. We subtract 8, 9, 10, 11. We get 3 left over. We put the 3 on the top and we put the 8 on the bottom. So we end up with 1 and 3/8. But what do I do with that 1? Well, since this right here has a whole number in it, and I'm pulling that whole number out, that 1's going to go into the 11. And that 11 will become a 12. And then the leftover fraction, the 3/8, is what we have remaining. So we end up with 12 and 3/8. So we just do 11 divided by 8. So we ask, how many times does 8 go into 11? One time. Well, where do I put that 1? I put that 1 into the 11. That's why it becomes a 12. And then I subtract these two to get my new numerator, and then I keep the 8 on the bottom. And then we ask ourselves one last question. Can I simplify the 3 and the 8? Because what if that 3 ended up being a 4? Well, then the 4 and the 8, they have something in common, and you still may have to simplify a little further. So those are the steps to adding mixed numbers. Now, what if I just had subtraction? What if I had a subtraction of mixed numbers? Do we do the same thing? Yes, we do. We start off exactly the same way. We write new fractions. Oops, not there. And then minus 4. Okay, and we ask ourselves, we start with the 9, and we ask ourselves, can I turn that 6 into a 9? No. So I do 9 times 2. Get 18. Could I turn that 6 into an 18 using multiplication? Yes, we can. So that becomes my common denominator. And then I ask, how did I go from 9 to 18? Times 2. So 7 times 2 gives me 14. How did I go from 6 to 18? Times 3. So 1 times 3 is 3. And now we subtract. 14 take away 3 gives me 11. Keep the 18. And then now subtract the whole parts. 9 minus 4 is 5. Most common mistake on a subtraction problem is we subtract everything with our fractions, but yet we add our whole parts. Got to remember it, subtract everything. Subtract everything. And then we ask, can I simplify my 11 over 18? And no. Now, if this were a 10 over 18, then I could divide both of those numbers by 2, and it would simplify down. Okay? Now, that's the old stuff. Now, this one's a little bit trickier. So let's see if you can remember how to do this one. It looks just like that last one. Okay, so let's try. Okay, so I'm going to rewrite. I'm going to find a common denominator. Okay, so the 4 and the 3, can I turn that 3 into a 4? No. So I do 4 times 2 is 8. Can I turn the 3 into an 8? No. 4 times 3 is 12. Can I turn the 3 into a 12? Yes. So we got a 12. Okay, so now we do our numerator. How did I go from 3 to 12? Times 4. So 1 times 4 is 4. How did I go from 4 to 12? Times 3. So 3 times 3 is 9. Now in the previous example, we had 14 take away 3. I could do that. In this example, I've got 4 take away 9. Can I do that? I cannot do that. Okay, so this is where you've got to remember that we have to borrow. Okay, just like in regular numbers, if I had 1,000 and I'm going to subtract 422, in order to get a number here, I have to borrow. And I got to go to the first number that's available to borrow from. So I'd come all the way over here to the 1. Well, the same thing happens with a fraction or mixed number. You got to go to the first number that's available. And the number that's available is actually that 4. So here's, in essence, the long version of how to borrow. Okay, I can't do 4 take away 9, so I'm going to borrow 4. The 4 is going to become a 3. Well, the 1 that I borrowed, I need it to look like a fraction. Well, a fraction that's equivalent to 1 is the same number on top as it is on bottom. But I have to make sure that it's got the same denominator. So that means it's 12 over 12. So that part right there is my 4. But then I add to that what I already have. And so I would end up with 3 and 16/12. Okay? Now, that's the long version of what happens. Now, let's talk about the short version. What I really want you to do when you're borrowing is you borrow from the 4, it becomes a 3. Well, my denominator has to be a 12 because I've got to use common denominators. But what we really do to find our new numerator is just add these two numbers together. Add the 4 and the 12, and that gives us our 16. Now, the whole purpose of doing that is so that my numerator on this fraction is big enough I can subtract the numerator on this fraction. So now it is, so I can do 16 take away 9, which is 7, keep the denominator of 12, and then 3 take away 2 is 1. And then we ask, can I simplify this? And we cannot. Okay? So we've talked about 3 things today before we go to the new thing. We've talked about how to add mixed numbers. We've talked about how to subtract mixed numbers without borrowing. And we've talked about subtraction with borrowing. So now this brings us to our lesson for today. So if you remember back in our I will, or our we will, oh, didn't go far enough back, it says that we're going to add or subtract positive and negative mixed numbers. So what if I throw in some negative mixed numbers? So now we got to think about our integer rules mixed in with our mixed number rules. Now these aren't integers, but we do still have to apply the integer rules, okay, because we do have positive and negative numbers. So when you look at this particular problem, this number right here, the 8 5/8, is a positive number. This 3 1/2 is a negative number. So with our integer rules, if you remember, if it was addition, we had 2 rules. Signs alike add, signs different subtract. So in this particular problem, my signs are different. So what am I going to do with my numbers? I'm going to subtract my numbers. Okay, so in this one right here, we now know that we're going to subtract our numbers. So now I need to go through the same process that we went through on either this problem or this problem. And again, the first step is to find a common denominator. So 8 new fraction, okay, plus -3 new fraction. And now, here's the 8. Can I turn this 2 into an 8? Yes, I can. So 8 becomes my common denominator. Okay, so did I do anything to this 8 to turn it into an 8? No. Leave it as a 5. Did I do anything to this 2 to turn it into an 8? Yes, I did. I multiplied by 4. So I'm going to multiply this by 4 to get 4. And now, because my signs are different, even though it's an addition problem, because my signs are different, I'm going to subtract my numbers. So 5 take away 4 gives me 1. I keep the 8, and I do 8 take away 3, which gives me 5. Now, which number is farthest from 0? Which number has the greater absolute value? The 8 5/8 does. So this answer is positive. Okay? So what I want you to do, okay, I'm going to give you one question, and I want you to work this problem. Okay, let's see if this is the one I want you to do. Yeah, this one right here. This is the one I want you to do. I want you to pause the video and then answer this question. This will be the last question for today's lesson. Okay, let's see how you did. Let's see if you remembered what to do. Well, the first thing you'll notice in these two numbers, that one of them's negative, one of them's positive. Okay? And I hope you noticed that it was a subtraction problem. Now, because it is a subtraction problem, because it's got integers in it or got integer rules in it, what did we do with subtraction? Well, we changed subtraction to addition, next number to its opposite. We can do that with mixed numbers as well. And now you'll notice that both of my numbers are negative. So that means if my signs are alike, I'm just going to add them together. But my answer will end up being negative in the end. So now, we rewrite my problem with common denominators. I've got a 5 and a 4. The first number they're going to have in common is a 20. Now, what did I do to this 5 to turn it to a 20? Times 4. So 2 times 4 is 8. What did I do to this 4 to turn it into a 20? Times 5. So 3 times 5 is 15. And now, because my signs are alike, I'm going to add my numbers. So 8 and 15 make 23 over 20. And the 5 and the 4, they make a -9. Now, our last step is to simplify. And if you'll notice, my fraction is improper. So we ask ourselves, how many times does 20 go into 23? It goes one time. Okay, so where do I put that 1? I put that 1 into the 9. So that becomes a -10. And then I subtract these two numbers, 23 take away 20, gives me 3, and then I keep the 20 on the bottom. And that is my final answer. Now on Tuesday, when we come back, we're going to review these topics one more time, and then you're going to have an assignment to complete. Now this particular assignment, this one's going to be a little bit different than the ones that we've done in the past. Okay, because this one I am going to require you to show me some work. Okay, so that means you're going to do the assignment on your notebook paper, and you're going to take a picture of it, and you're going to attach it in Google Classroom to this assignment. And that's the part that I'm going to grade. Okay, so Tuesday, we'll do the assignment. So today, on Friday, all you have to do is watch the video and take notes. That's what you should have been doing while we were doing this particular lesson. And you can watch it over and over and over again in order to make sure you understand this. Because on Tuesday, you'll have an assignment over positive and negative mixed numbers. So until then, I'll have a good weekend, and I'll see you later.